Okay, thank you for coming. Today we'll be talking about layer 2 security. In this case, it's the MACsec, MAC address security. Yeah, it's been a long time. We haven't done any webinar. uh, yeah, looks like in 2023, uh, we had a lot of stuff needs to be done. So yeah, we try to commit to do a webinar uh, this year, 2024. So this is the first webinar in 2024. So hope you enjoy it. So this topic today will be talking about the security, especially in layer 2, especially with technology that is called MACsec. Yeah, these are the agenda. We're talking, and the thing is, we do official format, usual format, or some review, talking about some issues in layer 2, especially related to security, and then we talk about MACsec, and then some live practice, but I don't think it is necessary because I already take some screenshot how you implement this MACsec, as well as implementing the how's the performance of the MACsec. Okay, we'll see that. Okay, so for those who are new, so we are GLC, Garda Lintas Cakrawala. We are based in Bandung, Indonesia. We do MikroTik, sysadmin, and then web development. Okay, so this is me. My name is Achmad. I'm based in Bandung. I do Linux networking, and then develop web application, web-based application. So this is our experience. Yeah, so we do network support, billing integration, application development. Yes, we do develop our own applications like billing and then other stuff. So because we think that if you just do networking and then yeah, that's not enough. Okay, because the customer wants the solution, right? Yeah, some previous you can see more details in our website. Okay, for those who are new, welcome. Yeah. And then we assume you already know TCP/IP, MikroTik, of course, routing protocols, firewall. But actually, this one is not really. You can skip this one. At least you know TCP/IP, okay? And then, of course, the MikroTik. Okay, so let's do some review. We already know the 7 OC layer protocols, and then we know the concept of encapsulation. Yeah, so if you send a data and then the data will be wrapped into we call it the wrapping in the technical form is by adding header of that chunks of the data. So this is your data, right? Okay, and then we add TCP header, we add more header, and then we add header, including the MACsec. Right, but we'll see how it looks like, how the MACsec looks like later on. So as you can see, this is what you type, hello, and then this is what you really send. Okay, so yeah, so yeah, this is how communication works. Yeah. So when you say something in WhatsApp or in chat application, actually you're not only sending that. So a computer will add more and more information so that your data uh, arrive at the destination. Okay, so here we know about router and routing. Router is the hardware, routing is the process. Okay, and then so when we put in topology, when we draw a topology, this is how it looks like. Okay, and then we have physical topology, and then we have logical topology. So the difference is in logical topology, we are focusing on layer 3. Okay. And then talking about on layer 3 on to the top. Okay, so that on logical topology, logical connections, we don't see layer 2 technologies here like switches, access point, and other stuff, other cables, right? Okay, so this is how the routing table looks like. Okay, so basically routing table is like this, right? So you go to destination, and then here's the gateway, here's destination, here's the gateway. So that's how it looks like. And then this is you can check your understanding about how the routing table works. And then this is where the routing table lookup happens in MikroTik process. And then here you can see yeah, how routing works. Okay, so it's like it is like a signboard when you are driving on the street. And then yeah, that's how it looks like. So if you are in a junction, and then that depends where you want to go, and then you check the signboard, and then that's the gateway you are taking. And then we need to know that routing is asymmetric, so a path for outgoing is different to inbound. Okay, next concept is the ARP, address resolution protocol. Basically, is the protocol that bridging layer 3 and layer 2, especially in Ethernet. Yeah, so if you are using Ethernet or Ethernet-based technology, which is a lot, yeah, Ethernet, of course, the wireless LAN, yeah, it's very popular because yeah, the price is affordable. Okay, so the thing is, as I said, what's the annotation? Oh yeah, yeah. So this is the header, right? Okay, so this is how the ARP request looks like. Okay, so you have a destination MAC, source MAC, and then here's the field for type, and then here's the ARP. Okay, and then inside the ARP is the, yeah, this is 28 bytes hardware. Yeah, this is the consists of hardware type, protocol type, source MAC, source protocol address, target, and then target protocol address. Okay, yeah, this is how the app looks like. So, for example, PC number 1 wants to talk PC number 5. Yeah. So in the beginning, both party must understand, but must have um, information about layer 3 and layer 2. Okay, layer 3 is okay because I want to ping 8888. Okay, but on layer 2, what is the MAC address of layer 2? Yeah, that's the issue. So that's why the PC number 1 is requesting MAC address of PC 5. Okay, what is I want to talk to 192.168.0.5, but I don't know the MAC address. Okay, that's basically this operation. Okay, so ARP request here, right? And then PC5 will reply, okay, I am this IP address. See, it's replying the request, and then this is the MAC address. Okay, so that's how you figure out the MAC address. Okay, so this concept is very, 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 very crucial. Yeah, and as a network engineer, you are expected to understand this concept. Okay. Yeah, so putting all together, for example, so if host A wants to ping host B, right? So in the layer 3, so we don't have an issue because when we open a terminal, we just ping. So we open terminal of host A, we just ping 10.0 to 90, okay? And then when the frame leave host A, this is what happened, okay? Yeah, this is what happened. Yeah, so this is the source MAC, and then here's the destination MAC of this one, okay, of the gateway. So that's the function of the gateway. So host A will send the frame to the router, to the gateway. Okay, so host A, when you configure host A, you must configure a gateway there, and then the gateway will be translated into MAC address. So that's the purpose of putting a gateway there, just to get the MAC address of the router. And then the router checks the routing tables, right? Okay. Oh, actually, it's not on 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 the same network. So I have to route, I have to forward the frame to the other network. So in this case, this network over here. Okay. So yeah, so the router forwards. Okay. We don't see any changes on layer 3, but uh, on layer 2, we change it, the MAC address, yeah, especially source and then the destination. And then the router knows the MAC address of host B after the ARP operation here. Okay, so that's the important concept. Right, so moving on. So layer 2 security issues. Yeah, so security, yeah, this is just a theory, not just a theory. I mean, yeah, understanding. Okay, that's the concept. So we have a CIA. So when we talk about security, it's the protection of assets, several aspects: confidentiality, integrity, availability, prevention, detection, reaction. So the concept for this one, the understanding of this one, you can, I think, already been discussed by many videos out there. So I don't want to repeat that again. Okay, let's talk about the understanding about the definition of attack, mechanism, and services. Okay, attack is the activity or action, and then mechanism is action, yeah, or process to detect or mitigate, prevent from the attack, right? And then the service is the target. And then this is how it looks like. Okay, if it is normal flow, just like this, from source to destination, everything goes well, everything is okay. But when we have an attack, what's going on? So sometimes it happens, we have an interruption, so the packet do not reach the destination. Well, this can be a security issue as well. For example, a file is deleted, uh, and then database is is not functioning, cable is cut, right? It's security issue as well. Okay, so that's interruption. So packets do not reach to the destination. And then we have interception. Okay, so packet is flowing, but in the middle, somebody is there for stealing the data, right? Or modify the data like this. Okay, and then can be fabricated data. For example, if I know the username and password, right, I can log in by myself, right? Yeah, it's a fabrication. So these are the attack types. So we have active and passive. Okay, so active means the attacker is actively doing the action like interruption, making the interruption happen, and then make a modification, and then do the fabrication. Or passive means that I'm just passively waiting for the traffic that is flowing. Okay, so I just sitting down and then watching the traffic, and then the traffic will be copied to my server, right? Yeah, yeah. So passive attack is difficult to detect because it's passive, right? Just passive. For active attacks, it is easier to detect compared to passive, because passive is just passive. When the information flows, I just copy the traffic and then nobody knows. Okay, as simple as that. And then we don't know when we are sending data in the in the internet, and we don't know what's going on over there. That could be somebody stealing our information, right? Not stealing means yes, yeah, okay, stealing by literal means. Okay, they just copy our traffic. Yeah, so it means that if they have a capability, they can see what we are sending. Okay, some attacks, especially in layer two. So we can see the attack for network discovery. So for example, MikroTik has MikroTik discovery. So if you log into Winbox and then IP neighbor, you can see the neighboring MikroTik device next to my MikroTik device. Okay, same with the Cisco device and then Ubiquiti and then other vendor as well. So usually that service for discovery, device discovery is turned on by default. And then this service, we can do attack, right? Next attack is ARP spoofing. Okay, so as we discussed earlier, yeah. So let's say PC4 is spoofing. So instead of PC5 sending, oh, okay, I'm PC5 and this is my address. PC4 also does spoofing. Okay, I'm PC5 and this is my address. Yeah, it is possible like that. Okay, so yeah, that's the ARP spoofing, and then DHCP. Okay, so this some happens. Yeah. Yes, I got a report DHCP attack happening several times. Yeah, not often, but yeah, it happens. So some attacks, DHCP starvation. So one host sending lots of DHCP. What is it? Not discovery. This DHCP request, sort of like that, so that the DHCP server will allocate the IP address for that particular host. Yeah. And then the all IP address in the DHCP pool is running out, and then the legitimate host, legitimate clients will not get any IP address. Okay. Next can be a DHCP rogue. So it means that in one network there are two, one same network there are two DHCP networks, which is not good. Usually, clients will get the DHCP from the closest DHCP server, right? And then, as I said previously, sniffing, yeah, passive attack. This can be done by traffic capture. I mean, for example, you are tapping um, tapping a traffic. Okay, you have access to a switch, and then you modify the switch that where all traffic on this port will be mirrored to particular port. Yeah, it's from the attack perspective. Yes, it can be attack, but from the switch perspective, it's a feature. Okay, feature to attack. Yeah, it's possible. Some mechanism. Yeah, we can do encryption, right? So we transform data into something attacker cannot understand. So we just encrypt. So even though you're encrypting, even though you capture our traffic, you cannot understand what's inside. And then we have authentication. Make sure that only legitimate user, yeah, login. Authorization means the role. So after you log in, and then this is the area you can access. Okay, so like a firewall, for example, or application roles. For example, you have an admin, you have a super admin, you have a admin level low, level 1, level 2, level 3, sort of like that. And then we have auditing, yeah, checking what is happening by any evidence. Okay, so let's talk about MACsec. So MACsec is Media Access Control Security. It's working on layer 2. We have a standard from IEEE 802.1AE. So it can provide confidentiality, integrity. Confidential means only only um, only particular party can understand. So it's confidential, even though you capture the frame, yeah, you the made the message, yeah, you capture the message, but you don't understand what inside because we for example we encrypt them, yeah. So that's the aspect of confidentiality, integrity, authenticity, yeah. The encryption method, default encryption method for MACsec. So MACsec is encryption, yes, encryption. So it's using this encryption method. So sniff. So therefore, uh, yeah, sniffer only able to display layer 2 header only, yeah. And then the if the attacker modify, yeah, and then it will have a detection that the header is modified. Okay, so the header is open, yeah, it's written in plain text, but the payload is encrypted. Okay, so MACsec on MikroTik is still in early stage, doesn't support dynamic key management, and then doesn't support hardware acceleration encryption. So as you know, when we talk about encryption, it involves lots of mechanism for calculation. In this case, and when we talk about calculation, it means that it needs support from the CPU. From sorry, it needs power for computation, and then the one that is doing computation is the CPU, central processing unit. Okay, so if you, yeah, so that's the consequence if you apply encryption. All right, so there will be a CPU usage, additional CPU usage for doing that. We'll see the performance later on. Okay, yeah. Okay, so this is MACsec stack, how it works. Okay, so first it discovers the session, yeah, with peers using MKA, MACsec key agreement. So inside, they have a CAK, okay, connectivity association key, and then they exchange CKN. So there will be two parameters that you need to establish: CAK, CKA, yeah, and then CKN. Okay, and then after they generate the SAK, okay, secret association key, and then they will do SAK, yeah, security association key, and then they will use this SAK for encryption. Okay, so this is how it looks like. So this is Ethernet. This is a plain text. This is without MACsec. Okay, and then after MACsec, this payload. It means that layer 3 header, layer 4 header, and the other header will be put here. Okay, it will be encrypted. And then we have normal Ethernet frame here. Okay, and then we have a security tag, and then we have a check to make sure that there is no tampering in our frame. Okay, so that's how MACsec looks like. Okay, so let's talk about the deployment and performance. So this is my topology in my lab. Yeah. So this is me. This is my we are doing we have a two hosts. Host number 1 connect to router 1 via switch 1, And then I have a MikroTik router here acting as switch 2. And then this switch is MAC address, MACsec support as a MACsec support. Okay, and then this is the host 2. Okay, so I will compare with and without MACsec. Okay. Okay, let's continue. Yeah, so MACsec support on switch. Well, that depends on the switch itself. So if the switch does not support MACsec, okay, so it is normal switch like this. So it means that we need to establish MACsec, uh, connection from end to end. So from host to host, okay. So here we have a physical interface. Here we have a physical interface, and on top of that interface, we are creating a logical interface for MACsec. Okay, and then this MACsec will connect to the other MACsec. Okay, so if somebody is doing capture here, packet capture here, it will not display the content. Okay, right. Okay, so that's how it looks like if the switch does not support MACsec. So what if it does support? Okay, so it looks like this. For example, this host 1 and then host 2, right? And then what it does is, as usual, it creates a MACsec interface. Host 2 also create MACsec interface, but the peer, yeah, in the previous one, we create a MACsec interface with the peer from end to end. Okay, so here's the end to end, not end to end. I mean, yeah, peer that which is directly connected. Yeah, but if the switch supports a MACsec, so MACsec here will connect to the switch. So on the switch side, we need to create a MACsec logical interface as well that connects to this. Okay, understand? So here's also MACsec interface on the switch. Okay, so you need to configure the switch to connect to this. Okay, so from here to here, it is encrypted. From here to here, also encrypted. Okay, so that's the difference between MACsec on the switch. On the switch that is supporting MACsec and then without MACsec. So as you can see, it really authenticate the device. So yeah, that device needs to have a security. So one port, one host. Yeah, and then we we uh, we make sure that the host that is connected to the switch is the legitimate host, because we are creating a MACsec for them. Okay, so let's talk about the MACsec on MikroTik. Oops. Okay. Yeah, so this is MACsec on MikroTik. Okay, so for example, I'm at the host side, and then I connect the host directly to a switch, MikroTik switch. So this is the switch side. So from here, as you can see, I'm connecting via Ether 5, and then here I created a MACsec interface, logical interface here. Okay, things that I do is I just define the interface that I'm running a MAC address on, and then I define CAK and then CKN, and then on the switch side, I use Ether 2. I create a MACsec logical interface here, okay, and then here's the details, and after that I define this MAC address is running on Ether 2. And then, I define CAK and CKN here. So CAK has to be similar, otherwise it cannot connect. If it is successful, and then this is how it looks like, open encrypted. Okay, so that's how you define MACsec on MikroTik. Right. Next is what happened after the MACsec. Okay. Okay, let me change the color. Okay. Yeah. So let's say I do an attack. So on the switch, I do like a port mirroring, right? So I just capture all traffic that is happening there. So as you can see, before I implement MACsec, and then here I have a telnet session, right? And then as you can see, I just disclose everything I got. Yeah, so I got layer 2 header here where I can see destination MAC address, source MAC address, and then here's the type. Okay, type, field type on the at the layer 2 header. Also, I can see layer 3 header here, IPv4. Okay, it explains, actually the type here explains the protocol that is used on after the layer 2 header. And then here's the layer 4, which is TCP, right? Here TCP layer 4. You can see port, destination port, right? And then here's the telnet data. So yeah, you can see everything. Next, after the MACsec, this is what happened. So as you can see, the protocol here only display MACsec, right? And then here's the maximum you can see. So on layer 2, this is how it looks like. Okay, you still see, you still be able to see this one here. Okay, the destination MAC address, okay, source MAC address, but the type here is different compared to this one. Okay, so here and here are different. And then here we have a MACsec security tag, right? The ICV, and then here's the things, okay? And then here's the data. So actually I do telnet before and after MACsec. So actually I doing telnet also here, but as you can see, even though I capture all the traffic, but I cannot see what's inside. Okay. Okay, let's talk about performance. Yeah. Well, as you can see here, this performance is done on the switch. Okay. So without MACsec, I just run bandwidth test from host 1 to host 2. This is what I got. Okay, so yeah, I do bandwidth test. CPU is only 5%, as you can see here, 4 to 5%. And the traffic it can deliver is up to 50 to 100, sometimes 140 actually. So this is TX and RX. Okay, I do bandwidth test with both direction, transmit and receive. But when I activate the MAC address here, CPU goes to 100% here. Okay, and then the traffic is very, very low. Only able to deliver 12, 5. Yeah. So as you can see, as I said previously, when you are doing encryption, there are lots of computation, and then the computation needs compute power, and then one hardware that provides that compute power is the CPU. Is there any way to offload the CPU usage? Yes. You can apply special chips that is designed specifically for doing the computation, especially encryption computation. So yeah, and then you can increase the throughput here. All right. Yeah, so that's how the MACsec looks like. Okay, so if you ask me, is it possible to apply MACsec on MikroTik? Yes, yes, for some circumstances, yeah, it is possible. But regarding the performance, no, there is still early stage of development. Okay, so any questions? Hope you clear. Okay, so if you are interested, you can join our class. Okay, if you have a consultation, we also open a consultation. And then here's the end of slides. Please submit your feedback here. Yeah, further events will be available in our website. Here we have Facebook. Slide will be available on SlideShare. Discord, yeah, in Bahasa Indonesia, yeah, here. And this recording will be available on YouTube. All right, so I think that's all. Thank you very much and have a nice day. Bye.